Today we're going to continue learning about right triangles. We've looked at Pythagorean theorem and special right triangles. Now we're going to move on to trigonometry. So what I want you to think about is back in section 5, it's been a little while, we talked about similarity, and shapes that are similar, they have the same angle measure and the sides are proportional. Okay? We also talked about this back when we talked about dilations. Dilations produce shapes that are similar, meaning the angles are congruent, but the sides are proportional. Well, what we're going to look at now comes about from similarity and everything we studied about similarity. And we're going to use this for the ratios for right triangles. So since we know that similar shapes have ratios, the side lengths are proportional, the ratios are equal, they have come up with these ratios for us for a right triangle. The ratios are called sine, cosine, and tangent. And those are abbreviated like SIN, COS, and TAN. Those are ratios of sides of similar right triangles. All right, where do I begin? So let's see. So first of all, when we talk about these ratios, okay, there's always going to be a right angle because we're working with right triangles. There's also going to be what's called a reference angle. In this case, our reference angle is going to be right here in this corner. And the ratio for whatever this angle is, okay, the sine ratio is going to be the length of this leg that's opposite from this angle, from the reference angle, over the length of the hypotenuse, okay? Cosine of this angle, again, these words just are talking about the ratios between all of the similar triangles that have this angle measure. Cosine is going to be the length of the leg adjacent. Remember, adjacent means beside, like touching. Adjacent to our reference angle over the hypotenuse. And tangent is going to be the opposite leg divided by the adjacent leg. The way you can remember this is SOHCAHTOA. The sine ratio is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this SOHCAHTOA is what you need to remember these ratios. All right, let's do some examples. I know this is very new for some of you, but it's really not that challenging. So first of all, this says express the sine of U. That means that U is our reference angle. And if I would have put a reference angle up here, then it would have a different opposite and adjacent. So it is very important that you pay attention to which angle is the reference angle because it's going to be different. It's going to have different ratios. So the reference angle here is U. Whatever comes after sine, cosine, or tangent is always going to be an angle measure. So U is our reference angle here. That's going to be a number of degrees. Your reference angle is never going to be the 90-degree angle, okay? So the reference angle is always going to be one of the other two angles that's not the 90-degree angles. All right, sine. Our ratio for sine, if you remember SOHCAHTOA, and you can remember the SOH, the sine ratio is opposite over hypotenuse. So we need to look back at this triangle and figure out which side is opposite from angle U, and then which side is the hypotenuse. Okay, if I'm looking at this triangle, angle U is this angle right here. What is the length of the side that is opposite? Opposite means it would be this one over here, so that would be 12. And what is the length of the hypotenuse in this right triangle? The hypotenuse is always going to be across from the right angle. It's always going to be the longest side. So the ratio is going to be 12 over 13 for this triangle. It says, as a fraction in simplest terms, can I reduce 12 over 13? No, I can't. So my answer for this would be 12 over 13. That means that any triangle that is similar to this triangle, and what does similar mean? Similar means that all of the angles would be congruent and the sides would be proportional. The opposite and adjacent sides of any similar triangle would have a ratio of 12 over 13. Okay, so we write it as a fraction in simplest terms, and you can see Delta Math even uses SOHCAHTOA. It's pretty common way to remember the trigonometric ratios. All right, let's do another one, except this time we're going to find the value as a decimal. So we're going to do the same thing, but as a decimal. Okay, and this says find the value of sine of C. So again, we're using sine, which is opposite over hypotenuse, and C is our reference angle this time. You would get a different answer if you used a different angle. So this is angle C. Okay, again, sine is going to be the opposite over the hypotenuse. So let's look at what side is opposite from angle C. 11 is opposite from angle C, and the hypotenuse is what's across from the right angle would be 20. So 11 over 20 would be opposite over hypotenuse. This time it wants us to put it as a decimal. So we can pull up the calculator, and you might need to round for these. So be careful to, if it's a fraction versus a decimal, make sure you're careful about that. So 0.55 is what we get for the ratio of the opposite and hypotenuse of any triangle that is similar to whatever this triangle is. All right, let's do some more. This one says cosine of Q. Q is our reference angle. So whatever comes after sine, cosine, or tangent is going to be an angle measure. The cosine of Q. All right, for cosine, we use adjacent over hypotenuse. Adjacent over hypotenuse. Remember, adjacent means beside the reference angle, and hypotenuse means across from the right angle. Okay, our reference angle, again, I recommend always circling or marking the reference angle somehow. So Q is our reference angle here, and cosine of Q is going to be the adjacent, which means beside, over the hypotenuse. All right, if I'm looking at angle Q has two sides that are adjacent to it, okay? So the 25, though, is the hypotenuse. So what ratio would I use? The adjacent side would be 11. The hypotenuse would be 25, because that's the one across from the right angle. Since this says rounded to the nearest hundredth, and it says value, we're not going to leave it as a fraction. We would actually divide that 11 divided by 25 to see what decimal we get, and that is a ratio of all similar right triangles that are similar to this triangle. Okay, let's do another one that is tangent. Remember, tangent is going to be opposite over adjacent. Tangent is the only one that does not use the hypotenuse. To find the tangent of angle G, make sure you are careful about which angle is your reference angle. This is angle G. And again, we know that tangent is opposite over adjacent. Okay, opposite over adjacent. You can remember TOA. Tangent is opposite over adjacent. All right, so let's figure out which leg is opposite from angle G and which one is adjacent. This would be the opposite from angle G, would be the one that it does not touch. That would be 2. And then the adjacent would be 24. Not the hypotenuse. Tangent doesn't use the hypotenuse. Okay, a fraction in simplest terms. So how would I type in this answer? I would need to reduce this fraction. I could divide these both by 2 to get 1/12. Okay, you might want to remember also that this calculator will simplify a fraction for you if you click on functions and then fraction. It'll simplify a fraction for you. All right, some more. Find the value of cosine of V. So again, I'm going to circle my reference angle, which is V. And cosine means I use which sides? Adjacent over hypotenuse. All right, so looking back at this triangle, the side that is adjacent to V, but not the hypotenuse, would be this side right here. Okay, you're always gonna, the hypotenuse is going to be adjacent, but the adjacent that we're using here is the side that's beside it, but not the hypotenuse. Okay, cosine is going to be adjacent over hypotenuse. So the side that is adjacent is 3 units long. And how long is the hypotenuse? Uh-oh, it doesn't tell us how long the hypotenuse is. Do you have any ideas for how we could know or find how long the hypotenuse is? I hope you do, because we know that the relationship, anytime you're given 2 sides of a right triangle, you can find the third side by using Pythagorean theorem. So, some of these are only going to give you 2 sides, and you need to find the third side using Pythagorean theorem. Okay, how could I plug this into Pythagorean theorem? Well, 3 and 4 are my legs, because those are the 2 that form the right angle. So, I would do 3 squared plus 4 squared equals c squared. That's going to be 9 plus 16, and that's going to be 25. So, what is the length of this leg? That would be 5. By the way, 3, 4, 5 is a common, what we call Pythagorean triple, meaning those are 3 whole numbers, that a squared plus b squared equals c squared. If you're good at memorizing things, you might want to memorize Pythagorean triples, because it could save you a little bit of time. But 3, 4, 5 is probably the most common one. Okay, so I did all that to find the hypotenuse, because I need to know the ratio for adjacent over hypotenuse, because that's going to be cosine of the cosine ratio of any triangle that is similar to this one. Okay, it says round to the nearest hundredth, so I would just type in 3 over 25, get what that decimal would be as a decimal, and round like it tells us to round. All right, now we're going to look at actually finding the length of a side using these trig ratios. So the reason why these ratios are important and helpful is that they can help us to find missing side lengths and missing angles. So the thing that's going to be different about these is they're going to actually give us an angle measure. Unlike the other ones we've done, they didn't give us an angle measure, but this does give us an angle measure. And that's going to be our reference angle for these types of questions, is the one that has an angle measure. So this wants us to solve for x. How are we going to do that? Well, we only have one side length. If we had Pythagorean theorem, if we had two side lengths, we could use Pythagorean theorem, but we only have one side length, and we have an angle. So anytime we have a side length and an angle, we can use our trig ratios. All right, what I'm going to do is figure out which sides I have for this reference angle of 69 degrees. All right, this side I'm trying to find, what would that relationship be? That would be the adjacent leg. Okay, so what I'm trying to find is the adjacent leg. And then 10 is which part of the triangle? That would be the hypotenuse. It's the longest one across from the right angle. Now we look at our ratios and figure out which one involves the adjacent and hypotenuse. That would be cosine. That means we're going to want to use cosine to figure this out. All right, so we're going to say the cosine of x degrees, so the cosine of 69 degrees, okay, equals, and then I'm going to do adjacent over hypotenuse. So what would adjacent over hypotenuse be? That would be x over 10. Because I know that anytime I have a right triangle with a 69-degree angle, there is a ratio that is the same for all of those similar triangles. All right, next what I'm going to do is solve for x. And I want you to think about, if I wanted to get x alone here, what could I do? I would need to get rid of dividing by 10, so I could multiply by 10 on both sides. All right, now when you multiply, we're not going to multiply the angle number by 10. What we're going to do is take and type this into the calculator. You can use the graphing calculator, you can use the Desmos calculator, you can use the Delta Math calculator. They all have trig functions in them. So when I pull up the Delta Math calculator, okay, and I'm going to type this in, I'm going to type in 10 times, and you actually don't even have to put that times there. I'm going to go to functions. Now, remember it says make sure your calculator or Desmos or this calculator says degree and not radian. And then I'm going to type cosine. So 10 cosine, and then I'll type in 69. Okay, and that is in degree mode. So that is the length of x based on the ratio of a right triangle with a 69-degree angle. That tells me that this leg would have to be about 3.58, but if I round to the nearest tenth, that would be about 3.6. So let's recap a little bit. What I needed to do first of all is figure out which parts of the triangle that this used. It used the adjacent and hypotenuse, so I used cosine. I set up this proportion. Okay, I looked at getting x alone, and I plugged that into the calculator in order to get what that would be. All right, so it's just a process, the same process each time. Let's do some more. Solve for x. So again, this time it gives me a side and an angle. So I can't use Pythagorean theorem because you need two sides to use Pythagorean theorem. So instead I'm going to use these trig ratios. All right, let's figure out which ratio we can use here. The angle that it gives us is angle E here. That's going to be our reference angle. And the side that we're trying to find is this one. Would that be the opposite leg, adjacent leg, or hypotenuse? This leg would be the opposite leg. Okay. 5.7. Would that be the hypotenuse or the adjacent leg? Adjacent means beside or touching this angle, so this is the adjacent leg. Okay, it's not the hypotenuse because it's not across from the right angle. So which one of these ratios uses adjacent and opposite? That would be tangent. Remember, tangent is the one that doesn't use the hypotenuse. So we're going to set up our trig ratio again. Tangent of x degrees. So I'm going to write the tangent of x degrees, which is 26 degrees, equals, and then how would I say opposite over adjacent? I'm going to put x over 5.7. Okay. Next, I just need to figure out what x equals. And if I want to get x alone, then I just need to get rid of dividing by 5.7. And how do I get rid of dividing by 5.7? I would multiply by both sides by 5.7. And when I type 5.7 tangent 26 degrees into this calculator or your regular graphing calculator or the Delta Math calculator, you can type in or you could go to the keyboard and click on tangent and that kind of thing. That's going to give you the length of the leg. Okay, so go ahead and try that. See what you get if you type in the 5.7 times tangent of 26 degrees. 5.7, I'm going to go to functions and click on tangent. And make sure you don't click the one that has a negative 1 there. 5.6 times the tangent of 26 degrees is about, if I round to the nearest tenth, about 2.8. So that means the length of this side is about 2.8 based on the ratio of all right triangles that have a 26-degree angle that are similar. The ratio of the sides is, for the tangent sides, is this ratio. All right, and let's do one more. Solve for x, and the, the reference angle is 72 degrees here. All right, let's figure out which ratio we're going to use here. The 72 degrees, I have this x and this 8.8. First of all, this x, is that the opposite leg, adjacent leg, or hypotenuse? This is the adjacent leg. It's not the hypotenuse, but it is touching our reference angle. And by the way, if this was our reference angle, it would not be adjacent, right? So it all depends on the reference angle. 8.8, is that the hypotenuse or the opposite leg? That is the opposite leg from our reference angle. All right, which one of these ratios involves adjacent and opposite? Again, that's going to be tangent. So I'm going to put that the tangent ratio for 72 degrees, okay, opposite over adjacent. So how would I set that up? I would do 8.8 over x. Now, this one's a little bit different from the others because the others that we solved had x on top. This one has x on the bottom. So this is why I put a little note for you that whenever you have something that you're dividing, you can flip around the denominator and the answer. Why? Because if 10 divided by 2 is 5, 10 divided by 5 is 2. These are the same thing. All right, so what I'm showing you is that you can switch around when x is on the bottom. You could do this swap. You could do this swap because something divided by something, it's the same thing. So you could switch those around. So if I switch these around, I get 8.8 over tangent of 72. So when you have x on the bottom, you're going to want to switch these around because anytime you are dividing, you can switch this around, because if 8.8 divided by this is this, then 8.8 divided by this is this. All right, so then all you would need to do is type in 8.8 divided by tangent of 772 to get the length of that leg.